Yeah, problem one. The guitar has 6 strings. How many strings are on 3 guitars? Write a multiplication curve.
All right.
6 times 3. 18.
6 times 3. Because you're multiplying.
Okay, so far so good?
16.
It's everything you said. It's like a little video. But watch what I'm going to do next, and I want to see if you can kind of explain it. Oh, it's slow. They get better. They get faster.
Oh, wow. What did I do?
No, hit the,
what?
No, this video. No. Yeah.
Okay.
All right. See you with us?
Yeah, I'm here.
All right. Talk about what happened on this step of the video.
1 times 6 equals 6. 2 times 6 is 12, right?
Okay. This wasn't a good one to start with. I'll explain it since I want to explain it, and then I'll give you one to explain. Really this week I wanted us to work on something called the distributive property. Have you guys heard of it before?
Wow.
Yes. And I found myself really struggling to find the words to explain it, and so I thought, okay, let me just work out a couple problems to show you. And here's like the most basic start of it, not the most basic, but like a problem that we can wrap our minds around, because you guys knew off jump that I was going to say, all right, 3 guitars, 6 strings each, that's 18 strings altogether, yeah?
Yeah.
Okay. In the picture, what I circled in yellow, I represented as 1 times 6. Just to make sure, which of these represents the size of the group and which one represents the number of groups?
The 1 is the number of the groups, and the 6 represents the size of the group, right?
Beautiful, yeah.
Okay.
And so down here in green, we have 2 times 6. And what does that 2 represent?
Hold on, the size of the groups, right? The size of the group is 6.
That's the group of 6, yep, because it's 6 strings per guitar.
Okay. And 2, I guess how many? Oh. Oh wow. You know what I'm trying to get to, Miss Camilla. You always get me to try to explain something, and you know I'm not good at explaining my answer.
You say that, and yet I love it when you explain. And everybody else does too. Morgan, same with you. You guys are both really insightful when you're explaining your thinking of it. So the 2 represents the number of groups, and 6 still represents the size of each group. Right?
I'm writing that down now. Then the size of the group, right? Right, Miss Camilla?
I don't, what was, say it again?
And the 6 represent the size of the group, right?
Morgan, do you think that that's...
Write down my notes. I'm taking my notes.
Let me kick it to Morgan. Morgan, do you think that she got that right?
Yeah.
Why?
Because
I think it's the size of the groups.
What is?
Because
I know. It's not right.
Two.
I can
Oh, I see now. Because one group is just with 6,
Mm.
and then 2 groups is just with. They okay, so they did it by they did it by how, like, they did it by like how many what's it called, like they separated it to make it 2 and then 1.
That's deep.
How is it deep?
Because this looked like a bunch of mumbo jumbo when we first had it all scribbled on the screen, and you just made sense of it out loud. Instead of straight up 3 groups, they had 1 group and 2 group. They separated it. And so, see, does that help you determine if 1 and 2 is the size of each group or the number of groups?
Yeah, I done already wrote it down.
Love it.
I'm down here trying to work one time the problem at that bottom.
Ah, okay, let's look at it. What's this yellow 1 times 6?
I know how to do that.
Okay, well, explain it to me then so I can learn with you.
Okay, so so 1 times 6 plus 2 times 6. Let me get my jogging ready.
2 times 6
Okay.
is 12, plus 1 times 6 equals.
You put 6 over. You put. Hold on. I'm trying to. Yeah, I know what I'm doing. So 6 is 6. That is 0. So you slash that out, and so you do 1 times 2. You do 1. You do 1 times 2.
See, Miss Camilla, she know what she doing. She just don't know how to explain it. You get us lost with that. She know what she doing.
Yeah. Okay.
Take your time.
So you put the 6 under the. You put the 6 under the 0.
What 0? Sorry.
Look, you know that.
No. I really don't.
6 is 6 is 0. So you're not going to put the 0. You just gonna put the 6 under the 6 and just slash it out. You can't use that.
Okay, I'm officially lost.
Are you?
Okay, so let's do it. Okay, let's do it. Can you write, Miss Camilla? Can you
That is a great question.
Can you like write on here?
Yes. If I.
Okay, can you take this away and make it just a screen so you can write and put the problem on there?
Yes. Let me do that.
But I'm gonna show you a way that we can do it, take it easier.
Okay, that's
All right. So you guys are gonna remember what it looks like.
I got it
Yeah.
written down.
Okay, good. So let me say stop share. Oops. Let me re-invite myself on the iPad. Accept. Let myself in.
Yeah, I teach tech too. I know. I know.
One more second. I'm ready. You don't see it. I see it. You don't see it.
That's the weirdest thing.
Pop up.
Okay.
There.
Whiteboard.
See it?
Yeah, see the board. We don't see
Amazing.
nothing on it though. Okay, she writing now.
I'm just gonna write down what was on there from before.
One times 6 and 2 times 6.
All right, Morgan, take it away.
Hold on, Miss Camilla. Hold on. For she take it away. Where did the 3 did the 3 times 6 come from? It says equal this. Where did that come from? You lost me.
Great. Okay. So, whether though this is distributive property, so no.
I'm sorry. I'm sorry. Didn't do that on purpose. Go ahead.
So put the six.
Just tell me what to write. If this is not helpful, I don't even need. I can erase the whole thing.
No.
Should I erase? No.
No, I just want you to talk me through
No.
how to solve it.
No. Okay. Can you do an arrow to the 6 and then the arrow to the 2?
You said an arrow through the 6 and the 2?
It's like, do like a, no, not those type of arrows.
Oh.
Like a thing, like this.
Okay.
Like that?
Yeah, but I want the arrow to go to the 6 and the other 6.
Oh, Morgan, I think I know what you're doing. Is it something like this? Like first, outside, inside, last?
Yes.
Oh, good. But I'm going to stop you. That is the distributive.
Okay.
But that is the distributive of like algebra. And this is me just trying to introduce distributive as an idea.
Okay.
So you made your math teachers proud. You did identify where you last probably did see distributive property. Oh, sorry. But I'm not going to have you explain it right now because it's a couple steps ahead of where we are. Is that okay?
Yes.
I think I can make this all come back together though with actually what you're doing. So let me take a quick step back and then I'm going to meet you back over there. What does this represent? What, Morgan?
1 times 6.
No, I would say, should we do a problem that's before you?
Yeah. But no, right. No. But here, I'll even write it down so that I remember to come back to it.
Bless you.
Thank you.
Mm-hmm.
Yeah, I remember that. Okay. C.
Yeah.
1 times 6. We said 6 is the group size. 1 is the number of groups.
6.
In the problem we were looking at, this whole little expression, 1 times 6,
Mm-hmm.
represents the number of strings on how many guitars?
Yeah. It's 6 strings on 1 guitar.
Beautiful. 6 strings on 1 guitar. Now the 2 times 6 in the problem we were doing represents what?
It's 2 guitars and 6 strings on each guitar. So that's 12.
Yes.
That's how we get the what's the name? This is what we don't. Cause you got it like the 1 times 6, and then you got the plus, and then this. Okay.
Yeah. So this is, you said 1 guitar.
18 altogether.
With 6 strings. Then we have 2 guitars. Six strings each, right?
So, Ms. Camilla, let me ask you something. With this first problem and the second problem, right? Where you got 6 plus 12, after you did the multiplication for the other 2, would you add them together and you get the 18? Or them too far ahead?
Oh, you're perfect.
I need more practice to this to get the hang to it, because I was lost.
And so, this 1 times 6 represented 1 guitar. The 2 times 6, 2 guitars.
Mm-hmm.
When we add it together, 1 plus 2 is 3 guitars, right?
Mm-hmm.
That's where originally I had gotten, let me save this picture. Hold on.
I see you showing your work too.
Mm-hmm.
That's something you can get on me all about. I get the answer, but you be like, you didn't show your work.
Yeah, can't talk through it, and really ain't nothing going on.
Mm-hmm.
Well, something's going on, but not enough. So that's what I had up there originally.
Huh?
This 1 times 6 plus 2 times 6 equals 3 times 6. I had that up there originally, and you were like, hold up, hold up, hold up.
Oh, yeah. I didn't understand where you were getting it from. Now I understand.
Explain it.
That's where that 18 came back from. Hold on. Equal. Let me put this back up there. 3 times 6 equals that 18.
So what we did that was distributive was we took 3 times 6, right? 3 groups of 6. And instead of counting like 6, 12, 18, we kind of split up how we thought of it. Instead of 3 groups of 6, we were like, well, that is the same as 1 group of 6 plus 2 more groups of 6.
Yeah.
Altogether, 3 groups of 6. The fact that we can break up this 3, right, the number of groups, into 1 group and 2 groups, or 2 group and 1 group, that is what is at like the heart of the distributive property.
Okay.
And I'm going to give us lots more examples. Okay?
Well, put one up there so I can try.
I'm going to have you explain my work, okay?
Oh, God. Let's see that. Morgan can do that part. She can explain the work.
Okay, let me pull it up. Close this. Close this. So I'm going to have it walk through the work, and I want you to talk it out.
7 times 3 is 21, right?
Good. Let me play.
Let me get my phone so I can cheat right. My wife's phone right here. I can just use her phone. My dumb phone getting stuck. Let me get my damn phone. That's what I was doing for trying to use her phone. Oh, that's a lot. Okay, hold on. We got 5 groups of 3s. Okay, that's 15. That's 6. Okay, I got that.
There's your 15.
I mean, yeah, I put the 15. I put the 21 over 7 times 3. And then I put 6 under 2 times 3.
So where did the 15 come from?
The 15 came from 5 times 3.
Mm-hmm.
15, 16, 17, 18, 19, 20, 21. Okay.
Where did the 6 come from?
2 times 3. And that bring just them 2 alone bring it down. Oh my God. So, okay, I think I got it. I think you put 5 groups of 3, so if you get confused on 5 times 3, you can always count them and know that you mean your 15. And then you got two groups of 3 underneath. You got that, so if you get confused, you can always count and find your answer. Right?
Beautiful. So beautiful.
Okay.
Like beautifully explained. All right, so over on the right-hand side where I have that number bond, that was just me kind of making sure that my brain understood why I was doing 5 and 2. It's because 5 and 2 is 7.
Mm-hmm.
And there I just kind of summarized, right? 5 3s is 15, like you said. 2 3s is 6. Together is 21. Good. Ready for another one?
Oh, yeah. What we doing? Because you just said 6 times 4, so I'm doing the math to that. That's 24.
Yeah.
But I'm confused why you got 5 times 4 right here.
Because I'm going to try to use the distributive property.
Okay.
And just how on the first, like the one before this, you were like, oh, maybe the person, so they don't have to recount, it's going to just start with like 5 times 3 is 15. Here I'm starting with 5 times 4 is 20, because that's another one that's kind of easy to come back to.
Okay.
And so to find my 6 times 4, I wanted to use the distributive property, so I said 6 4s is the same as 5 4s and then 1 more 4, right?
Mm-hmm.
So the 5 4s shows up as the 5 times 4. And the 1 4 is the 1 times 4.
Okay.
And then underneath
So
that,
we
okay.
need to write it. We need to be writing this down now, or
Up to you.
uh,
Don't write this one down, write the next one down, okay?
okay.
This one we'll just talk through it. So I put 20 underneath 5 times 4.
Yeah.
Why?
Because that's how much 5 times 4 is. It's 20.
Good.
Plus 1 times 4, and that equals 24. That's the same thing as 6 times 4.
Exactly. Yes. It is not supposed to be more complicated than that. Let me see if I wrote it out as an equation or not. Good. Oh, were you just saying that, C? Thanks for making my point before it popped up on the board. Okay, here comes another one. Let me clear the annotation. This one is going to be what? All right, so yeah. And I want us to use the distributive property. Okay.
4 is 28.
All right, so you already know the answer. And we're going to just, I'm going to fast forward actually.
4, 5, 4 equals. Got it.
How's that?
Hold on. I'm writing it like I did it before. Sometimes it's 28. Okay. Times 4, 20 plus 2 times 4 is 8. What do you want me to do with this cover? Because you add them together, this is gonna be 28.
Good.
So
Right now, I don't need you to do anything. I just want you to recognize and stick with me, which you did. Morgan, are you with us?
Yeah.
Great. Now I'm going to fast forward. I hope the next one I did was 12. Is it? Ugh. 9 times 4. All right, I'm really taking it step by step.
okay, hold on. 8, 36.
How'd you solve it, C?
36. I know a little multiplication, but I wrote it down 4 9s, 18, 18, 36.
Ooh. I'm so happy you said that.
I ain't trying to make nothing harder than what they already got me for me. Yeah, that's about right.
And the way that you did it, hang on, let me annotate, save. Stop annotating. Stop pause share. If I may real quick, see what you just said. You said you'll just do 2 times 4. I'm sorry, what am I saying? That's not what you said at all.
You guys, I got the answer for 9 times 4. And I told you, I wrote down 4 nines. 18, 18, make 36.
Yep. 9 times 2 plus. So instead of doing, right?
Mm-hmm.
So originally I had, like the work I just showed, I did 9 4s, and then we split it into 5 4s and 4 4s, right? C, you thought of it a different way. You thought of it as 4 9s, and then you did 2 9s and 2 9s, right?
Yeah.
Brilliant. So C used the distributive property, and she has enough experience multiplying that she kind of gamed it out and was like, it's way easier for me to do 4 groups of 9 than 9 groups of 4.
But
right?
at the end of the day, people saying do it however it makes it easier for you or some way that you can remember, and that's how I remembered it. So
no, I think it's perfect, and I just like it because if I write it like this, I can show that you are already using the distributive property intuitively in a different situation. So that what I'm putting up here is not so different. It's just I'm doing it maybe differently than how you would have used it. Like I'm applying it differently, but the strategy is the same.
It's the same, right?
And going back to sharing.